All right, section 5.4 is all about solving radical equations. Okay. Now there are actually two parts to this chapter, or to this section, and one of them is radical equations, and one of them is radical inequalities. Now the radical equations have three separate things that can happen. There's three different methods or things that can happen in equation form. When you're dealing with radical inequalities, there's only one real thing that can happen, and once you know how to solve these, it shouldn't be a big deal at all. So we're going to start out with equations and kind of beat that to death, and hopefully understand what it means. But the three things that can happen. Number one is you have one radical on one side and one term on the other. So I'm going to keep all of this very general so that you can kind of see what it looks like and you can kind of identify the form, because some of these are going to work in increasing difficulty. Number one is the easiest, number three is the most challenging. So when you work your way through this, hopefully you can kind of recognize it and get to know what's the easy part and what's the hard part. This one means that I have a radical on one side and one thing on the other side. That's what that's basically saying. Okay. So the first one is identified like that. It doesn't really matter what the thing is on the right side, as long as it's just one thing. It could be a 5, it could be an x, whatever it is, it keeps things pretty straightforward. The second one, this is a little bit more challenging, but still very doable for you guys right now. Even though you know how to do algebra, it just takes that one little extra step, because I think that a lot of people are going to forget it. The second thing is one radical on one side and two terms. So one radical on one side and then two terms on the other side. So hopefully you can kind of figure out what this means. This means that we have a radical on one side the same way that we had in the first one, and then we have two things. So like maybe an x plus a number, or an x minus a number, or something like that. This has two terms. Now this is going to be a very, very big issue for a lot of people. I'm going to put in little parentheses or asterisks or whatever. I'm going to put the word FOIL, because a lot of people are going to forget to FOIL this. Because remember, to get rid of a radical, the same way that we just did in that SAT example problem, you square things. And if you square things, that means you have to square both sides, which means that I would have to square this right side. And if I square that right side, that means I'm going to have to double distribute. A lot of people are not going to double distribute, and that's where the issue is going to show up. Okay? And then finally, the number 3 is radicals on both sides. This one makes us sad. This one's hard. Not hard, tedious, and it takes a long time. So it's one of those ones where like one of these questions could take upwards of 5 to 10 minutes, just because it's very tedious. And in order to get the radical away from one side of the equation, you're going to create either equation 1 or equation 2 after that. So it's just a lot of stuff happening, lots of things that will make you very sad and angry if you have to do a question number 3. Stressy, messy, depressy. All right, so let's solve one of these. See what it looks like. Starting out with an easy one. The first thing that you can identify right now is that there is a radical on one side of the equation, right? So you would see that right away. There is a radical on one side of the equation. On the other side of the equation, there is one thing, right? There's a 4. Doesn't matter if it's a 4 or an x or a 12, it doesn't matter, as long as it's one thing and one thing only, which we can see that. You go about this solving it like any normal equation, right? Anything that you would ever do, normally you would treat this as if this is the unknown, and then you would isolate the unknown. So the radical is the unknown, you would isolate it and then solve, right? So we would divide by 2, and then I'm left with the square root of x plus 1 equals 2. Now we square both sides of the equation. So I end up with x plus 1 equals 4, and then I get x equals 3. These ones are the nice ones. These ones are the ones that you are not sad about, because they're very, very easy to deal with, because all you have to do is square one of the sides of the equation and you're done pretty much. All right. So that's something to kind of think about. But your first step with these always, actually with all of them basically, is to isolate the radical as much as possible. So isolate it as much as you can. So like in this case, notice how we divided by 2? Dividing by 2 helps us to isolate that radical. So hopefully that's nice. Hopefully you understand what's going on there, okay? The next one is a little bit more challenging, okay? So the next one is a little bit tougher. So let's say that we have something like this. Everybody good here? Oh, wait a second, just in case. So now this one, notice how we have a radical. We have one thing on the right side, right? So it still looks like it might be a nice one, but there is something different about this one than there was on the last one. The last one didn't have any addition or subtraction there like this one does. And remember my last thing that I wrote down on that last slide was to isolate the radical as much as possible. So what would I do to isolate the radical here? I would add 1, right? Just like we would with normal algebra problems, we would add 1. So we'd get 7x plus 15 equals x plus 1. Is this question type 1, 2, or 3 now? This is question type 2. So this is a little bit more sad for us, okay? It's a little bit sadder because now we have a little bit more work to do. You still do everything the same exact way. You're not changing anything about what you're doing. There's just a little bit more that you have to do, okay? So I still have my radical isolated. That's exactly what I wanted to see. So now I'm going to square both sides of this. But here's where the issue is going to show up. So if you are the type of person who makes common mistakes, like you look back at your quiz and you're like, man, I did this. Even though he said someone was going to do this, I still did it. This is one of those spots where you should put like a big red star and be like, this is something to pay attention to. Don't do this, bozo. So this is something to pay attention to, okay? When I square the left side, everything is fine. It goes away, no big deal. I'm going to put this in red just for a second because if you're the type of person who wants to see what the common mistake is, this is the common mistake. People might have made the mistake already.
What's the right answer?
So remember what I put next to number 2 on the very first slide where it said FOIL? Remember what x plus 1 squared means. X plus 1 squared means x plus 1 times x plus 1. So you have to double distribute this or you will lose an answer. Okay? So if you don't double distribute, you will for sure lose an answer. So that's the issue that people make. So do not put x squared plus 1 as your answer. And I'm telling you right now, even though I'm saying those words out, even though I wrote it in red, even though I told you to start, someone will do it in this class. It will happen. Don't let it happen to you. Okay? Make sure that when you're practicing these, you understand not to do that. So here, I have x times x, which is x squared. I have x times 1, which is going to give me positive x. I have 1 times x, which is going to give me positive x. And then I have 1 times 1, which is going to give me 1. So it's almost the same thing, except we're missing that little 2x term in the middle, right? So now this question turns into 7x plus 15 equals x squared plus 2x plus 1. Now this is why these get a little bit tedious, because now we have to use quadratics to solve this. We either have to factor or we have to use the quadratic formula. Okay, so that's what we have to do. That's the issue that we have to kind of work through, is there's a lot of solving, simplifying, and then doing more after you've done that. Okay, so in order to solve a quadratic, you get everything on one side of the equation. So I am going to move everything to one side of the equation. I like the x squared term to be positive. That's how I like to move mine over on one side or the other. So the x squared term is positive where it's at, so I'm going to leave it alone. I'm going to move everything else to the other side. So minus 7x, minus 15. And then I'm going to be left with 0 equals x squared minus 5x plus minus 4. And now we have something that we can hopefully factor it. If you can't factor it, you will have to use the quadratic formula. Okay, so we should be able to see that we can factor this. We can call it x minus 7 and x plus 2 equals 0. And then when you solve this, you end up getting x equals 7 and x equals negative Now, big issue here, okay? We're still not done. Like I said, this is tedious. So since we're still not done, we have to figure out what else could possibly happen. I know that I have two answers right now. The only other thing that could happen from this moment on is that one of those two answers doesn't work, okay? The reason that one of those two answers doesn't work is because of this step right here. When we square something, we get rid of a radical. When there's no radical, there's no restriction, right? When the radical is there, I can't have the number inside the radical be negative, right? If the number inside the radical is negative, that instantly makes this a no solution. When you square it, you get rid of the radical, so you're basically saying there's no problem. So what you have to do at the very end of this question is figure out, do either of those answers make my original problem, do they make it bad? So you have to think about that, all right? So what we're gonna do is we are going to plug these answers into the original problem. 7 and -2 will get plugged into the original problem, okay? And we're gonna test them to see if they actually work or if they don't. So now I'm gonna check 7 and 2. So I'm gonna check x equals 7, and all I'm gonna do is plug it into this equation and then solve it and see if it's true or not. So I'm gonna get the square root of 7 times 7 plus 15 minus 1 equals 7. So 7 times 7 is 49, plus 15 is 64. So this is the square root of 64 minus 1 equals 7. The square root of 64 is 8 minus 1 equals 7. This one checks out, right? Yeah, gotcha. So 8 minus 1 is 7. 7 equals 7. We're good. So this solution works. I would say that x equals 7 is a good solution. This is one that I could put into my answers for big ideas, quizzes, whatever, and it would give me the credit for. When I try x equals -2, some of you might already see the issue, but some of you might not. So we have the square root of the square root of 7 times -2 plus 15 minus 1 equals -2. So now I'm going to end up getting the square root of 7 times -2 is -14 plus 15 is 1 minus 1 equals -2. So then when I continue solving, I get the square root of 1 is 1, 1 minus 1 equals -2, 1 minus 1 is 0. 0 is not the same thing as -2. This one does not work. So -2 does not work in my solution. Some of you might have noticed a couple steps ago that it doesn't work. Where would you have noticed a few steps ago that it doesn't work, or why? Does anyone know? So some of you are going to have to do all these steps the entire time. Some of you won't have to. Sam, you got it?
Yeah, because the square root has to be positive, and if you subtract 1, it can't be -2.
Beautiful. So what Sam is saying is he understands that if you take the square root of a number like this, it's going to be positive, right? Because if the square root is already in the problem, you only care about the positive answer. So what he sees is that this being a square root thing, we're going to take the square root, it is going to be positive. A square root, no matter what, if it's positive, -1 is never going to equal -2, right? Square roots can be 0, 1, 2, 3, 4, 5, 6, whatever. Any of those numbers -1 will never equal -2. So if you looked right here and you said this is not going to work because there's a negative there, that's totally fine. Okay? Other questions you guys can think of right at this moment? We're going to do one example of a tough one so that you can see what it looks like and you can see exactly why it's a tough one. Okay? So you're going to see why this is a tough one and why it sucks. Because it does. It's no fun. I'm telling you right now, it's no fun. And then it's going to turn into a problem that I want you guys to try on your own. So I'm going to start it out with you and work through kind of the tough part of it. And then I'm going to let you guys try to work on the rest of it to see if you can finish it off. And that'll probably be where we stop today. So right here, we can obviously see we have a radical on both sides of the equation. So it instantly goes to step 3, which makes us sad, right? And it should, because it's tougher. In step 3, you still want to do your best to isolate the radical. But no matter what I do, if I try to isolate this radical, like if I subtract 1 from both sides, I'm going to end up getting this now has a -1 over here. I'm either gonna have a +1 over here or a -1 over here. There's nothing I can do to isolate both radicals, right? So since there's nothing I can do to isolate both radicals, I'm gonna have to do something with one of the radicals not isolated anyway. So what you're gonna do is you are going to square both sides of the equation anyway. Okay, now the right side is easy. The right side is no big deal at all. The right side will turn into 3 minus x. No big deal. The left side is going to be a nightmare because we have to FOIL. This means the same thing as the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. And that's a really big bummer because now we have a lot of stuff going on. Okay? So we have to double distribute this. I would very strongly suggest that you write down the entire set of parentheses in order to double distribute it. So I'm going to have the square root of x plus 2 times the square root of x plus 2, which is nice because that's going to cancel. And it's just going to be x plus 2. Then I'm going to have the square root of x plus 2 times 1, which is going to give me positive square root of x plus 2. And then 1 times the square root of x plus 2, which is going to give me positive square root of x plus 2. And then the last one, 1 times 1, will give me a positive 1. So hopefully you can see now why this one stinks. So now what I'm going to do is combine everything that I can on the left side of my equation. So I have a positive 2 and a positive 1 that will combine to give me a 3. I have 2 of these x plus 2's here, so I can combine those and say that there's 2 of them. So it's going to end up being x plus 2 square root of x plus 2's plus 3 equals 3 minus x. Now this is what I want you to try, because this one is now a level 2 problem. So the thing that stinks about level 3 problems is once you solve a level 3 problem, it likely takes it back to a level 1 or a level 2 problem, and then you have to do it again. That's why they're really tedious. Okay? So again, I've combined these. The x is just right here. I have 2 square root of x plus 2's, 2 square root of x plus 2's. I have a positive 2 and a positive 1, which gives me a positive 3. The right side didn't change. So this is what I want you guys to attempt and do your best on, see what you can come up with, and we will finish that up tomorrow. Any questions you can make? Yeah, like.
How come it doesn't go from, instead of the x plus 2 plus x plus 2 radicals, how come it doesn't go from 2x plus 4?
Because remember, we don't add anything inside the radicals the same way that you wouldn't with x's. Like if you had 1x here and 1x here, you now have 2 x's together. The same thing, if I'm saying I'm holding 1 square root of 2 in my hand right here at x plus 2, 1 square root of x plus 2 in this hand, and 1 square root of x plus 2 in this hand, how many total square roots of x plus 2 do I have? I have 2 of them. You only combine the stuff inside the radical when you're multiplying. Yeah.
Does the 3, this is probably ridiculous, so does the 3 have to be on the right side of 2 square root x plus 2?
No. So your job right now, as of this moment, is to try to isolate that radical however you can. And if it cancels things, move things, get them all out of there.
I
Dude.
just didn't know if we should have started with that.
No, it doesn't make a difference how you start.
Yeah,
Nope.
I was gonna say it wouldn't.
Yep.